history, and discovery. Organic matter is residual matter made of natural, domestic, or industrial origin. We find it, for example, in human or animal refuse, in marsh sediment, in wastewater, as well as in domestic and agroalimentary waste. This matter is biodegradable. In other words, it decomposes through the action of bacteria present in the environment. When it decomposes in the absence of oxygen, like at the bottom of a swamp or in the digestive tract of ruminants, we call it anaerobic digestion, which simply put means in the absence of oxygen. This anaerobic digestion produces a gas called biogas. In 1776, Alessandro Volta, inventor of the electric battery, discovers that bubbles emanating from a swamp contain something other than air. He names it swamp gas, definitely biogas. He will later succeed in isolating its principal component, methane. This type of anaerobic digestion is in fact more commonly called methanogenesis. Utility of the process. But how can methanogenesis be useful? Well, thanks to the methane it contains, biogas is combustible. It can be burned to supply energy. Thus, while ridding ourselves of pollutant organic wastes, for example, liquid pork manure, we can produce energy. This is already being done close to some agricultural sites, garbage dumps, or wastewater treatment plants throughout the world, like in the Chinese village of Caotianba, where inhabitants cook and heat entirely thanks to the biogas they produce. Analysis of the process. But how is organic matter transformed into biogas? Thanks to bacterial action. Different categories of specialized bacteria work together to transform the components of organic matter to make biogas. They act like microscopic factories for chemical transformation. Let's look at that more closely. Other than hydrolytic bacteria, which fragment solid matter and make it water-soluble, we also find bacteria called acidogenic. They break down the complex components of organic matter into simpler molecules, alcohols and organic acids, acetate, and a bit of carbon dioxide and dihydrogen. The alcohols and acid products attract another category of bacteria, acidogenic bacteria. They become transformed into carbon dioxide and dihydrogen that they recombine in large part into acetate. Next, bacteria called methanogens take up the relay. Some combine the carbon dioxide and dihydrogen to produce methane. Others use the acetate and cast off methane and carbon dioxide in equal parts. They produce the final components of biogas, which is about 60% methane and 40% carbon dioxide. There is also the case of sulfur-reducing bacteria. They're not really a part of the transformation chain. They're attracted by the acetate and sulfur present in organic matter and produce hydrogen sulfide, a toxic and corrosive gas with a nasty smell. They compete with the methanogenic bacteria and may even stop the production of biogas. But biogas always contains some trace of hydrogen sulfide. This at least allows the identification of its presence and prevents intoxication. Diagramming the process. To see it more clearly, we will represent the process schematically. Even if practically the transformations fashioned by the bacteria operate simultaneously, we will separate them into 3 successive phases. Phase 1 is acidogenesis. The complex components of the organic matter are transformed into simpler molecules, alcohols and organic acids, acetate, and a bit of carbon dioxide and dihydrogen. Phase 2 is acidogenesis. The alcohols and acids are decomposed into acetate and carbon dioxide and dihydrogen. Phase 3 is methanogenesis. On the one hand, carbon dioxide and dihydrogen are assembled into methane. On the other, the acetate is decomposed into methane and carbon dioxide. As we have seen, this mixture of methane and carbon dioxide is biogas. Methanogenesis and bioindustry. A biodigester is a device that allows for the production of biogas while exploiting the methanogenic process. This biogas is sometimes used to feed generators which produce electricity. Depending on whether they are homemade or industrial, biodigesters may take many various forms. But the basic principle remains the same. Organic matter is placed in a closed reservoir without oxygen, and the bacteria does its work. We may improve the performance of the process by stirring and by temperature control. The biogas produced is then gathered in an expandable reservoir where it is forwarded toward a distribution network or electric power plant. We mentioned the Chinese example of Kaotianba, but you should know that the methanization process is also used more and more here at home. Initiatives in this field are at the heart of what is called the bioindustrial sector, hence the more currently used term biomethanization. For example, this Beauce farm, this Jonquilla cheese factory, or this Sainte-Sophie waste management site.